Now we are dealing with the module thin film techniques, and we have to explain the last topic also, that is the interference filters, multi-layer optical filters, and also the thermoelectrical power and applications of thin films. Interference filters. Interference filters are very important in the world of optics. The interference filters based on the phenomena of interference in the thin films are called interference filters. This can be broadly divided into two categories according to their categories: edge or cutoff filters, and the second one is band filters. Edge filters are those whose primary characteristics changes between a region of transmission and a region of rejection. This can be either short wave pass or long wave pass. The band filters have region of transmission bounded on either side by region of rejection and vice versa. Due to the advancement of thin film technology, very fine filters have been fabricated. And we have to deal with multi-layer optical filters. Multi-layer optical filters are fabricated to produce very region filters. A common application is in the fabrication of cold mirror, that is zinc sulfide in cinema projector to avoid the overheating of the film. The semiconductor crystal like germanium is transparent to IR region in the EM spectrum. Using germanium substrate for lambda by 4 thin film stack, it reflects in the visible spectrum. It reflects non-heating visible light and transmits heating IR radiation and thus forms a cold mirror. That is the cold mirror. Then in this case the average transmittance 80% is obtained with the germanium mirror. And cold mirror is a simple selective reflection filter and may be fabricated by depositing indifference combinations of dielectric and metal films on an opaque substrate or mirror. Then next is dark mirror. If semiconducting films transparent to IR are used, the mirror combination has negligible reflection in the visible and high reflection in the IR. Such system is said to be dark mirror. Dark mirror is useful in selective energy absorption for solar powered thermal system in the visible region without increasing the operating temperature. An example for dark mirror: aluminium, germanium, silicon oxide coating attains 20% reflectance in the visible and 90% at lambda is equal to 1.2 micrometer. So, at the temperature above 200 degrees Celsius, dark mirror loses its dark appearance because of the diffusion of Al to Ge. To avoid this diffusion, a thick film of SiO is placed between these two layers up to temperature 400 degrees Celsius without affecting the reflection. Then more examples for dark mirror is given and its specifications also given. Reflection interference filter. The bandwidth of central maximum decreases with the increase in number of units in the stack. Example is given. And anti-reflection coating is a broadband transmission interference filter. Example is given. And the variation of reflectance of the dark mirror coating as a function of wavelength of incident light is shown in this graph. So, we had discussed the topic interference filters and multi-layer optical filters. Next is thermoelectric power of thin films. Some researchers detect thermoelectric properties in the living creatures. The wasps could remain cooler than surroundings. They showed that thermoelectric power plays a role in the physiology of an animal. They argued that insects have a heat pump in their body which works using power generated from electrochemical reactions of body. When the shell exposes to sun, an electric current produces which keeps the body cooler than the surroundings. Even after decades, the researchers are exploring the thermoelectricity for making more practical applications, and these are the developments that researchers made on thermoelectric properties. Thermoelectric properties and temperature difference between two junctions makes the difference in conductivity of two metals in a thermocouple. At junctions, there will be diffusion of free charges from the metals, and the temperature difference causes rate of diffusion of charges to be different at two junctions, which result in the potential difference between these two junctions. The rate of change of thermo EMF with the temperature is known as thermoelectricity. Thermoelectric power is important term in the thermoelectricity. Thermoelectric power, we have many applications. The semiconductor metals alloys such as bismuth telluride, lead telluride, zinc telluride, cadmium telluride, etc. are used for thermoelectric applications. And the thermocouples used to detect the heat radiations. Thermoelectric refrigeration and thermoelectric generation are two important industrial applications. Cooling devices for seats in luxury cars and power supply for spacecraft like voyages are based on thermopower. Efficiency of semiconductor thermocouples can be increased by the control on the composition and the structure of material on atomic scale. The heavily doped semiconductors have significant applications in thermoelectric devices. And thermocouples fabricated from solid solution of conductors and semiconductors are widely used in thermoelectric generations in different temperature ranges. Nowadays, thin film based on thermocouples are finding application in thermoelectric cooling and thermoelectric power generations for microelectronic devices. In semiconductor thin film thermocouples, within N-type semiconductor hot end is positive and in P-type cold end is positive. The direction of flow of charges is from positive to negative ends in a battery. The pile of such semiconductor thermocouples used together constitutes a thermoelectric generator which can provide sufficiently large voltage required in particular applications. So, we have discussed the interference filters and also thermoelectric power of thin films. Hope you all understand the topics. Thank you. Now we have to discuss the problems from these two modules. All of you study well, stay safe.